have in Google Classroom, you have realized that Ms. Ramos is giving you the reactants, only the reactants. And based on that, you have to predict the products that will form. Ms. Ramos, how are we going to do that? Simple. You're going to use what you know about types of reactions just to predict the products. How are you going to do that? That's today's objective. For example, if you have, I don't know, sodium solid reacting with chlorine, which is a gas, what type of reaction is that one? Okay, so the only possibility, synthesis, because if I have two elements that they're reacting together, the only possibility is just to make a compound. That's a synthesis reaction. And sodium chloride is gonna be formed. See that? That even though you haven't learned about predicting you are gonna use what you know about type of chemical reaction just to predict the product. And this is a synthesis reaction because only one product is gonna be formed, which makes sense because you have two elements. The two elements are gonna be formed? That is impossible. And you learn in this class about 4 different types of synthesis reaction. When you have a metal and a non-metal forming an ionic compound, when you have, let's say that you have phosphorus reacting with oxygen, which is a gas, and then you have the phosphorus trioxide. That's another synthesis reaction. So if Ms. Ramos is giving you 2 non-metal, what type of reaction is that? Synthesis. It was going to be formed, okay, a covalent compound. Ms. Ramos, what is the 2 and the 3 coming from? Oxidation numbers. And I was teaching you that a long time ago. You don't know that, you have to go back and learn that. Okay, so in addition to these 2 types of synthesis reaction, Ms. Ramos was teaching you another 2. The formation of hydroxide. You know that hydroxide is a polyatomic ion, OH, okay? The formation of hydroxide. How an hydroxide is going to be formed? When you have the oxide of the metal plus water. See that? So if Ms. Ramos is giving you an oxide of a metal and water, easy piece, okay. I have the formation of a hydroxide. See that? So let's say that I have beryllium oxide plus water. What's going to be formed? A hydroxide made of beryllium and the polyatomic ion hydroxide. Questions about that? This is another example of a synthesis chemical reaction. Another example that we were discussing in class in synthesis, like within the synthesis reaction, the formation of carbonate. Okay, by the way, you know that carbonate is another polyatomic ion. How a carbonate is gonna be made? Easy piece, okay. Oxide plus carbon dioxide. You're gonna have the oxide of the metal plus carbon dioxide, and then the carbonate is gonna be made. Questions about that? Okay. Aluminum oxide plus carbon dioxide. Since you have an oxide of a metal and carbon dioxide, aluminum carbonate is gonna be made. Ms. Ramos, how do we know the formula? Oxidation number. And you learn in this class how to do that. And I told you that was important. You don't know how to do that, you Google that. Questions about that? So, 4 types of synthesis reaction. If we have more types, But we haven't learned that here in class. No, ya, hoy bueno, hoy está mejor. It's better, better.
He's coming again today.
Okay. So, over here, you have a metal reacting with a non-metal, producing what? An ionic compound. You have over here non-metal reacting with a non-metal, producing what? A covalent compound. See that? You remember that we're talking about synthesis. What is a distinctive characteristic of a synthesis chemical reaction? Only one product. See? Now we have the formation of hydroxide. In the formation of hydroxide, the reactant always are going to be the oxide of the metal, water. And we have the formation of carbonate, in which the reactant always are going to be the oxide of the metal, carbon dioxide. The difference between the formation of the hydroxide and the formation of a carbonate, water, carbon dioxide. Because the metal oxide is going to be involved one more time. Okay? Decomposition. Decomposition is the opposite of synthesis. Synthesis. So you're going to have only one reactant. So if I'm telling you to write the decomposition of iron to oxide, how are you going to do that? The decomposition. How many reactors do you have? Only one. So it's iron to oxide. Miss Ramos, how do you know that that's the formula? I was teaching you that a long time ago. That's an ionic compound. So it's going to decompose into the metal plus the non-metal. See that? The same thing. The decomposition of sulfur trioxide is going to decompose into the two non-metal. The decomposition of carbon dioxide solid, the two non-metals that made that element. Questions about that? Miramos, but besides the formation of ionic and covalent compound, you were talking about the formation of hydroxide and carbonate. Decomposition. Oh my goodness, what is wrong with this pencil? Decomposition of beryllium carbonate. So I have beryllium carbonate here. It's gonna decompose into the oxide plus, my God, yo no puedo creer que esto no haya acá. Carbon dioxide. Questions about that? No? And the same is going to happen for the hydroxide. Questions about that? Okay, mis Ramos, now we have sodium. We have that, mis Ramos. How are you going to predict the product? I don't have a metal and no metal. I don't have that. I don't have two non-metals in there. Do I have over there hydroxide? Decomposing. Do I have a metal oxide plus water? No. Do I have organic material burning in the presence of oxygen? I have an element and a compound. Element and compound. If you look at the synthesis reaction, you have, for example, in the first two, you have two elements. Do you have two elements here? So this is not the formation of an ionic compound. This equation doesn't represent the formation of a covalent compound. I don't have a metal oxide and carbon dioxide, so this is not the formation of a carbonate. I don't have the metal oxide plus water, so this is not the formation of a hydroxide. And when I'm saying that, see, remember that the composition is the opposite. I have two reactants in here, so this is not a decomposition reaction. Now, combustion. In a combustion chemical reaction, you are burning organic material. Do you have organic material there? One of the reactants is made of carbon, hydrogen, or oxygen. Do you have oxygen in the reactor? This is not a combustion chemical reaction. So what is the only one left? Replacement. Double or single? Okay, you have to look. Do you have to compound? No. So the only choice in there, single replacement. Because in every single replacement, you're going to have in the reactants an element and a compound. Now you have to analyze. Do I have a metal and an acid? Copper sulfate is not an acid. Now, you need to analyze. Is sodium able to replace copper? What is sodium? Representative metal. Copper is a transition. The rule, transition metals, they're going to be replaced by representative metal. So a reaction is going to take place here, yes. Because sodium is going to replace copper. Sodium sulfate is going to be formed and copper is going to be recovered. And this is an example of a single replacement reaction. Questions about that? Mis Ramos, let's say that instead of having sodium and copper sulfate, we have sodium sulfate. My goodness. Are you going to observe over... It's a single replacement, you want to see? Now, in the case that you have... sodium sulfate and copper, are you going to be able to see if you're going to be able to see a sign of a chemical reaction? Transition, representative. This one is not able to displace that from there. Question? No? This is an example when you have a metal with an ionic compound. When you have a metal with an ionic compound, you have to look at the activity series. Activity series. If you have iron 3 phosphate reacting with copper, are you gonna observe a chemical change? No reaction. How do I know that, Ms. Ramos? A picture that I was sharing with you through Google Classroom. Activity series is called. Copper, even though both of them they are transition metal, copper is less reactive than iron. You have that in your activity series. Questions about that? Ionic, see the pattern in the reactant. Ionic compound, metal. You have to analyze. If you have transition metals in both, you have to look at the activity series. If you have, representative metal in the compound and in the element, activity series to see if the metal that you have along there in the reactant is able to displace the other one. But when you have representative and transition, right away you're going to be able to predict what's going to happen. Questions about that? But this is not the only example that we have in single replacement. Single replacement, we have another example. Acids reacting with metal. And when you have an acid reacting with a metal, always you're going to have a chemical change. Always. And what happens when you have an acid reacting with a metal? An ionic compound is going to be formed, and you're going to be able to observe a lot of bubbles because hydrogen is always released. See, the metal is going to replace the hydrogen in the acid. Questions about that? No? You don't have any questions? Another example of the single replacement. Ionic compound and a halogen. And this part is easy because you don't need activity series. You have the periodic table. Fluorine is the most active, while bromine is the less one. In this case, chlorine is going to be able to displace over there the fluorine. The answer is no. So here you're not going to see a reaction. But in this case, you know what's going to happen? Fluorine is going to be able to displace that from there. And you know that they have a 2 because the halogens, they are diatomic. And this 2 that is coming over here, oxidation number of beryllium. Because the halogen, they have an oxidation number equal to -1. Questions about that? No? Double displacement is super easy because the only thing that is happening there is a switch. Always is going to take place. And remember that when you have an acid and a base, water always is going to be one of the products. And for combustion, you have to type complete and incomplete. For the complete combustion, carbon dioxide and water. Always. It doesn't matter what you have over here. As long as you have organic material, during a complete combustion, carbon dioxide and water. See that? It doesn't matter. Oxygen is always one of the reactants in a complete combustion, and the products carbon dioxide and water. Questions about that?